happened there? There he is. Okay. Hello?
Hi.
Oh, hi. All right. There's Jesse. There's Anusha. Hi. And there's Angela. Okay. I couldn't figure out how to do it, so I'm glad you figured it out because...
Oh, I didn't, but I did find it actually.
Okay.
So I'll be right back.
Okay. All right. Well, Jesse's going to come back in. So how's everyone doing, Angela and Anusha?
I'm doing great. I'm now an editor for this biological anthropology undergraduate research magazine at Columbia, so that's exciting.
Okay.
It's called Six. Yeah. But I'm still figuring out why my camera won't work on Chromium. So sorry if I'm just gonna shut up and try to turn my camera on.
So you're the editor for a new or a journal, or what is it?
Yeah, it's actually an old journal. It's safe here. I can send it to you guys.
Yeah.
I'll put it in the chat.
Okay.
Hello.
Hello, Jesse. All right. Hello, Anusha? Okay, yeah. You're available by chat. Okay, so welcome to the meeting. Jesse is traveling as we speak to the UK. He's on the train right now. And that's good for him. Glad to hear that he's doing pretty well. This week I was very busy with different things, and I actually presented on behalf of the group at two conference workshops. Hi, Jesse. The first was the IGSS, which was the Inverse Generative Social Science Workshop, and the second was the Cultural Evolution Society. It was a conference, but it was, and I'm going to talk about that in a little bit. So those went all right. So we have those, and we have those on YouTube if people want to catch the whole talk. Other than that, anyone else doing anything interesting this week? Yeah, we already kind of talked about Angela, and Jesse's been busy with trying to travel, so let me start off with the Slack review.
Yeah. Can you still hear me?
Yeah, I can hear you.
Okay. It's a little bit weird here. I can't go back to my call. Oh, here we go. Yeah, I mean, there's a bunch of things I could say, but I don't really know how to address them in the context of the meeting. I would just say, it's been quite a busy week of I basically started kind of two jobs this week, and I might say more about them later, but suffice to say, it's been busy, and there'll be some nice overlaps between some of them, but I'll explain those later in the meeting, maybe.
That's good. Okay, yeah. Yeah, I did forget about that, actually. In between moving, you had two jobs you started, so... let's see, I hit the wrong button.
Yeah, one of them is really interesting is biometric data acquisition, and I'm really curious, and also even scanning out the machine learning models behind classifying some of the data.
Yeah.
So it's not a machine learning position, but it might be very interesting to do that there's going to be a lot to talk about that one down the road, so more about that later.
Yeah, I was thinking about, you mentioned that in the Slack, I think in a private message, and I think that's something I was actually thinking about when you mentioned it, and I'm going to, maybe, not this week I'll present on it, but maybe we'll talk about it maybe next week, or there will be something coming up on that, let's just put it that way. So... Yeah,
I'm currently on the train for Tree, so I'll give some periodic updates about that, and once I'm off of all my training, it'll be a lot easier to talk. But I mean, they'll be able to say soon.
Okay. So we're at the Slack review. So if you follow along in your Slack, we're in the CGS group channel, and so this was one of the presentations that was at the Cultural Evolution Society. So this was the one that was they were actually both in the same session. So it was kind of like it had the feel of a poster session, but they had the full talks, and it was in Gathertown. So it was like in different rooms of Gathertown, and you would get to talk to people, and I don't know if you've used Gathertown, but you have an avatar, like almost looks like a little video game, but then you can also turn on your camera and speak to people. So that was nice. So that happened. I'll talk about the actual workshop and conference soon after this. Cognition futures, there's nothing really new except that the CogSci discussion group is still something we're looking to organize, as we mentioned last week. So we still have this need to put this together and schedule it. And if you want to attend, again, there's a link. You don't have to register for the conference, but Jesse and Anson, as co-organizers, should register for free. I sent the link in the email this morning, so you can do that, in the near future sometime. It'll be, just you go through it's free, you just go through the process, and I sent the coupon code. If you're interested in going, but you're not going to go to the conference, you can still come to the event, and we want to get as many people in as possible, just to have a nice, robust attendance. And, you never know. I don't know what we might advertise to people at the conference, but I haven't gotten any information on how to do that yet. So we need to, I did a workshop it's almost 10 years ago now, and at a major conference. And, it's a lot of work to get things together and to kind of get the word out. But, you'll probably get people filtering in from the conference, so it'll be, it's worth it though, because you have a full set of things that you can go back to. Let's see. I don't see anything new in these channels. Cybernetics. I don't think there was a lot of activity on the Slack this week, but I wanted to go through. I think Ethics Society and Tech had some things. Erin posted on this neat intervention being tested. Someone doing some research in AI fairness, and they're looking for product teams, or we're currently conducting a paid interview study to explore the potential of crowd-based tools to help AI/ML product teams test for systems for bias or unfairness. So this is something if you want to participate in that. And then let's see. I thought I had posted something else in this. Oh, I think it's in another channel. But there's this, this was from last week. Okay, so this is one of the talks. I didn't put a lot of talks in the Slack from the two events this week, but this is one of the keynotes from the Cultural Evolution workshop. And this is a brief history of cultural evolution. This is a keynote address, so it's like an hour long.
Okay.
That should give you an overview
Is that recorded?
What was that?
Was that recorded?
I don't think so. I don't remember who it is, but yeah. Oh, this is Alex Masudi, I think. And he did that was his keynote. But this is at the cultural, I'll talk about it after the Slack review. So yeah, that's, and I think there's more content on YouTube, but I'm not really sure. I didn't really annotate it or anything. Let's see. Anything else here? Tier maps. I don't see anything in the. Again, we have our acceptances in the email. I put in that. Let's see. I think Shruti and Jesse and Krishna and Ashk are all people who were accepted into the Neuromatch Academy one way or another. So Krishna is going to be a TA for the deep learning session. I think Shruti's is going to be in regular Neuromatch. And I believe that Ashk and Jesse are going to be in the deep learning session as participants. So congratulations to every one of those people. That's great work. It's a fun thing to do, and I guess I'm planning on being a mentor this year. I don't know, they're going to match us to people, so I don't know who the groups are, but it'll be a good time.
Yeah. If anybody knows mentors or people who are like versed in either neuroscience or deep learning, there's still a big need for mentors. I'm kind of involved with the volunteer outreach stuff, and if at all possible, somebody, just mention it to them, because the more mentors we have, the more people we can get into the conference. TAs as well. So if you know anybody, please send them my way, or just not mention the mirror matches and then reach out to them.
Yeah, that's good. So there's that. So that's coming up sooner than we think. Next month, actually. And so that's going to be... that'll be fun, though. It's very intense, but it's fun. I'm still trying to find some of the newer posts. Okay, so this one here, Metabrain Models. So one of the presentation at IGSS was on Metabrain Models. This is the talk here. So I posted the slides from this talk. This is on Metabrain Models, and it was pretty well received. As you can see, we had Bill Rand, who was the organizer of the workshop. He posted my presentation when I was presenting here, my presentation face here, and then here's one of the slides. So it was it was fairly well received. I got some good questions, and then this is one of the main I think the first talk where they kind of lay out the landscape for inverse generative social science. So if you're interested in the topic, this is a good slideshow to go through. This person has been doing this sort of thing for a while. They've been doing agent-based modeling and other sorts of related questions for a while. So if we open them up, I think I kind of talk about some of the ideas that they had, like the idea of solving a problem, a forward approach and a backward approach, and has a lot to do with emergence and other types of topics that you can explore using agent-based models. So, and the talks were pretty wide-ranging. So, I don't know if we have anything else in any of the other channels. I think we're almost done here.
I would just say for this Bill Rand, he's a really cool guy. He does a lot with agent-based modeling, and I believe social variations of that well. I think he's like a social scientist, and I forget, Bradley might know, but I think he taught one of the courses on agent-based modeling that I was looking into a long time ago when I first came to Leland. And so it's pretty cool that he mentioned our talk. So that's good.
Yeah. So that's good. Angela put a link into the Sapient Journal here. This is the thing she's editing from Columbia. Okay. So, hello, Krishna. How are you?
Hello, I'm fine.
Good.
So, how are you?
Pretty good.
It's been a while. I attended the meeting.
Yeah. How are you doing?
I'm better.
Good.
Better than before. So,
Good. Well, that's good.
that's
Yeah. Glad you're doing well. And I think Erin's here.
Yes, I'm here.
Hi. Okay.
Hello.
Hi. So let's see. Okay. Okay, yeah, Angela. Laptop is backing up. Okay. All right. So yeah, just So that was the Slack channel. Did anyone have anything to say about that? It wasn't very much in there.
I would just say thanks. Thanks again, Bradley, for kind of spearheading everything, because I've really been completely MIA for the last week or 2 weeks, 3 weeks maybe. So thanks for really, doing pretty much everything since then. So appreciate it.
Yeah, no problem. Just trying to push this stuff forward, and sometimes it's it's why you have collaborators. You have to help out, and so that's good. So let's see. I have an announcement to make. We had an acceptance this week. We had so again, I'll share my screen. Okay. So we had this developmental model of offloading abstract that it was Angela and Jesse were interested. So that's the author order here, and it was accepted by this offloading workshop. So this is I can't remember when this is going to be held, but we just got the email a couple days ago, and so they need a 15-minute talk on this. So that's again not too much work, but it's still we have to put all this text into the form of slides, and so I'll be like sort of putting together a template on that soon, and then we'll circulate it. I think we can use a lot of this, maybe a fair number of the slides that we already have, so it's not going to be too bad. And this is again, I have some other notes that I found on a couple things that I wanted to add that weren't in the abstract. The abstract was word limited, so it's kind of hard to get your idea across that quickly in that tight of a space. But if you find anything on this topic, if you think something might be relevant, put it in, I guess, in one of the channels. We can decide where, and we can put it together. So that's coming up. Then I wanted to get to the two conferences. So the first one, well, actually, I'll start here. The first one is this Inverse Generative Social Science Workshop. This was held by, these are people interested in agent-based modeling, a number of big names in the area. So like I said, Joshua Epstein, and there's Scott Page, who's a sort of a social complexity, a social science person, Robert Axtell, and then there Bill Rand, who was the organizer, and there were a number of people here who I'd never heard of, but are doing really great work. And so it was like a 3-day event. So there was a lot of diversity of perspectives here. A lot of people doing things like traditional agent-based modeling with NetLogo. So there's adapting an existing NetLogo radar model to this evolutionary model discovery idea. So this was a new model that they had come up with, but they were using a traditional platform. And so I gave a tutorial on NetLogo, I think last year, maybe last fall. And, so they're using NetLogo, they're using maybe some other platforms, but they're also sort of handcrafting things as well. And so we have a lot of opportunities here. If you go through this schedule, you'll see a lot of maybe different topics that we might be interested in following up on. I know that Ash and I were working on an agent-based model for vision, and so that was interesting because there were no pre-existing models. We couldn't really adapt anything, so that's the idea. You have these you have platforms like NetLogo where you have these pre-made models. You have different models like the segregation model and the ethnocentrism game, and there are a couple other models like swarming and flocking that you can apply to a problem, or you can create your own model, and you just have to work within the rules of an agent-based model, which is you have these agents. The agents are programmed in some way, so they have an autonomous sort of system within them, and then they interact on some grid or in some space. And so there were a lot of good talks here. The slides are on the. Not everyone's slides are up, but I think a lot of the slides are here. And then they have a YouTube channel, which I don't think they link to here, but that's another way to get the content. So it was a very good event. Let me put this in the chat so people can go check it out on their own. There's the link. Okay. And so that's that workshop. And then there's the Cultural Evolution Society, which was very good. It was a 3-day conference. So this was an international conference, but it was supposed to be held in Japan. It was held virtually. They used this platform Underline. So this gives you like the schedule, and it gives you the videos and the slides and everything. So I'm logged in because I'm registered for the conference, but if there's some piece of content that you really want to see, I can get it to you. I got a lot of the slides, for example. So they had these Q&A sessions. They had social learning, music, magic, ritual, and religion, technology, kinship. So they had cumulative culture, social structure. So they had traditional topics. Then they had this plenary talk on weird minds. So weird minds, does anyone know what that is? Does everyone know what weird minds are? It's Western industrialized. It's basically like Western industrialized and basically a culture that most of us live in. And the idea is that there's a lot of psychology research has been done in this area, and these are basically the people who are the subjects in a lot of these experiments. So you sample, 10 people, you sample 1,000 people from a North American population. A vast majority of those people are going to be weird individuals, meaning they're Western industrialized, affluent people. And so, but that doesn't sample very much of the human, very much a human diversity. So there's a lot of, they're non-Western peoples, they're people who didn't grow up around very much technology, but those people typically aren't included in a lot of these experiments. So, you do have cross-cultural experiments, but it's, it's something that they're trying to address, and by saying, this is what we typically, a lot of the, psychology experiments are really, and theories are really kind of based on this single sort of sample, part of the sample of humanity. So, so that was one thing they had that was really interesting. There were things like the cultural evolution of reproduction. That was actually pretty good. They talked about demography and how, demography is, if you look across cultures, it's fluctuating, and there are a lot of things that, have to do with sexual selection and other things that intersect with cultural evolution. So then there's things like non-human culture, which we've talked about in our group. Cultural transmission, which is a good topic that, it has a lot to do with sort of comparing it with genetic transmission or genetic inheritance. So it's an inheritance system, but it's drawing the distinction between culture and genetic inheritance. And so there were a number of interesting talks here. And then if I go back here, Okay. Then there were more here in this session. Then there was the evolution of cultural transmission, which was another good one. This is Marcus Feldman, who came up with sort of a population genetics derived model of cultural transmission, probably about 40 years ago, and he published a book on it. And so he's been working in this area. So it was a very mathematical talk, but it's also very interesting in terms of seeing what kind of models people are using to look at this. So, this is where you have cultural transmission, you have genetic inheritance, you have this what they call a dual process or dual inheritance model, where you have, of course, the two, they can operate in concert or they can operate independently. So it's a very interesting topic. Let's see. Then there's this, so we were in discussion section 2. And so we had 2 presentations in that. We had the, here's charting the future of academic fields with cultural evolutionary trajectories. And then here was the examining cultural evolution with contextual geometric structures. And so a number of other really interesting talks in this session. There was the evolution of science as an example of cultural evolution, which was an interesting one. There's also something in the Slack I posted, and I don't know which channel it was, but it was it could have been like events or something like that. I'm trying to remember. Maybe it was external conversations. It was a talk I posted that they had on funding opportunities. It may have been in admin lab. Yes, it was. Okay. So this is a private channel that only a subset of you are in. But this is an administrative channel. But anyways, I posted this in that channel. And this was funding opportunities, transforming the field of cultural evolution and its application to global human futures. So this is an initiative, I think, that they're trying to get off the ground here. And so this is funded by the Templeton Foundation. So the vision is tackle obstacles for early career researchers, tackle Western centrism, bridge traditional disciplinary divides, and bridge divides between scientists and policymakers. Kind of goes through some of this. So this is an example of something that they're funding in this area. This might be something really, this might be a template for something we do. It also gives ideas as to what people are looking for in terms of funding. I'm never really sure how many people. I guess this is a program, though. So it looks like they're funding 5 of these projects. I don't really know what the status of this is. But this kind of gives you an idea of, like, how this works. So there's a competition. And you just have to go through this process. It's, I don't know what kind of collaborators you need or whatever, but, and then they tell you what makes a good application. So, you have to kind of conform to this outline. I found that these outlines are useful, but they're not necessarily easy to follow because you have to, they just kind of give you, like they say, theoretically rigorous, but also novel in relevance to call. Well, that's probably pretty subjective, depending on where you're coming from. So I don't really know, but that's something that, if people are interested in, like, funding something, this is one, this is kind of one way to follow this and to see, what kind of a grant we can put together, or, so this is something to reference. I think in this area, it's a good template to follow. It just kind of gives us ideas about what they're looking for, what kinds of things that are interesting to those communities. And that's really when we do these submissions, what we're trying to ascertain is, like, what's interesting to a certain community. So as you can see, there is a link to the Gather Town for that, for discussion section 2. Then we had the third day, which was, I think, just kind of the end of it, genetic insights into language change. So there is a significant linguistic component too. So there's a long history of, like, connecting like genetic inheritance models and models of population genetics and phylogeny with language evolution. And so this was an interesting talk here. Brigitte Packendorf, and she's an anthropologist. So, people in anthropology do molecular anthropology, and the linguists are also using phylogenies for things. And so this is a very traditional, in the sense, connection between the genetic world and the linguistic world. So, and then finally we had a couple more sessions where we had one on development, which I checked out because we talk about development a lot in our group. And so there are a number of talks here. This one, variation is the universal. So this is the, linking cultural evolution and bringing it into developmental psychology. And the idea that the universal, people talk about cultural universals, but the one universal seems to be a variation. And then there's this one on the ontogeny of selective social learning. Young children flexibly adopt majority of payoff-based biases depending on task uncertainty. That was interesting. A lot of social learning and associated things. So that was the one development track. Evolution of technologies. I think we've talked about that. So this is again with like tool use and other types of related cultural things. Oh, insights from artificial life. Yes, there's a talk here, and we talked about artificial life. So this is measuring and classifying open-ended evolutionary dynamics. So you can see that there is a chat going on the right here, where if you had a talk here, people would ask you questions, and you could answer them in this interface. So this, I didn't actually go through this talk. You can download. I can get you the slides if you're interested. Yeah, this looks like an interesting talk. So they're kind of going through sort of from a cultural evolution perspective, this open-ended evolutionary dynamics idea. So this is interesting. Yeah. So I think that's it for the conference. It was pretty good. A lot of content here. As you know, when you go to a conference, especially a big conference, it's very hard to sort of keep up with everything, and there's a lot of stuff going on. Okay, so Anusha she had the acronym for me. Western educated, industrialized, rich, and democratic. And that's the full acronym. So that's the sort of the bias of a lot of psychology research. And so, this conference, because it's cultural evolution, they really wanted to pick that apart and show, maybe alternatives to that. So are there any questions on that? Comments? Okay. All right, so that was a busy week. I did want to go back to the cognitive affinity or the CogSci affinity group thing. I know that Jesse's not ready today; he's on the train, but I did want to go back to this. So this again is our CogSci affinity and discussion group. This is where we have, these different sessions, and then like the neural network models of cognition, which looks like the one that's closest to what we're trying to do. And we also have women in cognitive science, CogSci IPUI, International Cognitive Science Group, and then so actually this one here, the New Human Cross-Disciplinary and Cross-Cultural Inquiry of the Human Mind. So they're doing this, they want to bring together cognitive scientists and humanists. So this is that one, and then ours is going to be here, and so we have to figure out what we want to put in this. And so we talked about this last week. I said, the best way to do this is to have an introductory session, and then have maybe either breakout sessions or like more interactive activities that people can follow along with. I know it's like, we also have to keep in mind that this event is like in 6 weeks. So that's not a lot of time to prepare things. So we want to keep it like, accessible to our schedules. So I would, we gotta start on this, but I would kind of not go overboard with this. It's very easy to go overboard with the planning. So this is the Cognition Futures website, and this is probably where we'll use we'll have this as sort of like the portal, maybe. I know we talked about this last week, but I was curious, Jesse, is there a way to sort of, are there multiple pages to this, or is this just like supposed to be a single page endeavor? I don't know if Jesse's currently available, but there he is. Oh, you're really low. I can't really hear you. All right. Okay, he's gonna fix his mic.
So,
Yeah, there you go.
yeah, I was trying to like jockey between phone service and cell service here. The page itself can be updated quite a bit.
Yeah.
If I have all the time,
Oh, we lost him again.
huh?
Oh, I just lost you. Okay, there you go.
Hello?
Yeah.
I'll just leave it at that.
Yeah, you're not coming through very, very clearly here. Yeah. Okay. Yeah, it's not. Okay, there we go. He's going to put it in the chat. It can be updated, yeah. So, like I said, we can use this as a portal. I don't know, if they're like multiple, we want to make a separate page, or if we just want to update things on that page or what. But we'll figure that out. And we can also create like maybe some sort of, I don't want to create another Slack team. Discord server maybe, but I don't know. We have to figure out a strategy for that too. So that's something. That's all in the planning though. Let's see. Let me share my screen again. Okay, so that's to be updated, and we'll figure that out. Let's see where I'm going to go now. So there's another thing that needs to be, I'm going to get to the submissions in a minute, but we also have another thing that needs to be addressed is this. Well, I'll just go to the submissions now. That'll be easier. So the submissions document, we have like 57 things on it now. It's a lot, but a lot of these things have been resolved, so it's not so bad. I think we're all caught up except for one thing. As you can see, these little red tabs here, which are, mean that you're kind of like, this is in the next few weeks, so that's a sort of a tag for that. This thing, I don't really know what it is, so I think I'm gonna take this off. And I think this is on the other, like my other group has a document is like this as well, and so I think that's on there. So I'm going to grade that out. But then this one here, number 52, is the one I want to talk about. And that is this Gibsonian Information abstract, and submitting it to this International Study for the Society of Information. So as you can see, this is due this coming week on the 15th. And I think what we'll do is just submit the Gibsonian Information paper that was submitted to the CogSci conference and not accepted. You can just recycle that abstract and submit that. It's a 300 to 500 word abstract, so it's not that much space, and that would be a slot for a 30-minute long presentation, which you probably would have. So that'll be upcoming, and I'll take care of that this week. I might send it out. It's like, I think, Tuesday, so I don't know if there's going to be a lot of updating to it. But I think this one too, this unsupervised reinforcement learning, is probably not going to happen, so we'll gray that out as well. All right. So yeah, that's all good. So that's coming up this week, and I'll get that together, and I'll probably put that in the Slack if people want to look at it, just to get an idea of what we're going to do with that. And so, speaking of which, we have the Gibson. Kind of been revisiting this Gibsonian Information folder, and so we had So this is an idea that kind of came up with conversations with Jesse and Anson and myself, and we were talking about Gibson and direct perception, and then this idea of Gibsonian information kind of came up. And it's the idea, it's not Shannon information, but it's something else. And it's this sort of idea that there's information in the direct perception area. So direct perception is where you're taking in information from the environment. It might be a naturalistic environment. Like if you're riding on a train going down tracks, you can see sort of the optic flow, and that's the idea behind direct perception. It's also the idea that, you don't necessarily have this deep representation for, like, the visual environment, for example. So it's like there's a lot there, and the idea would be to kind of characterize that, in a very sort of broad way, and then maybe even differentiate it from Shannon information, which is, of course, a well mathematized theory of information. Okay. So we have this CogSci 2021 submission. So let me go into the actual paper just to show what we have here. So the abstract is, how many words is it? Let's see. Okay, Danielle was on this too, so I didn't want to exclude her from this. And we were working on this back in February. 150 words on this. So we still have room to expand it. So I didn't want to, I know it was a long time ago now, and we've had a lot of things happen since then. But I wanted to go back over this because I think it's something that is worth kind of moving forward. So this was written around the same, or this was worked on around the same time as the allostasis machines paper. So this was kind of supposed to be sort of another tentacle of that work. So the abstract, we propose this theoretical framework of information based on ecological psychology called Gibsonian Information. This framework is relative to the study of cognitive agents and even non-neuronal systems by exhibiting cognitive behaviors. GI provides a framework to study how observers make distinctions between stasis and motion in dynamic environments. Our outline of the GI approach also considers the role of embodied observers or naturalistic perception, and how affordances influence the extraction of information from the environment. So I'm just looking at this and highlight 3 principles for quantitative characterization: disjoint distributions, contingent action, and coherent movement. So these are sort of the roots of the mathematical model here. All right, and then we talk about affordances here. And I want to say follow up and elaborate, because I don't think that, I think at least we didn't really get too deeply into affordances in this. And I think that this part is probably a little bit naive here. This GI provides a framework. So this, if I were looking at this now, because you write something and you work on it and you say this looks good, and then you come back to it in a couple months and you say this doesn't look good. So, like what I see now on this is that I see that this is not that much different from like something like optic flow, which is well characterized. So what is it about this is so what is it about this that differentiates GI from optic flow or Shannon information, which is going to be the obvious question, but that's something that can be addressed there. I'm not sure that people on the CogSci conference domain really grokked this idea of non-neural systems, but I didn't really get any review points from that submission, so I don't know. But that's something that we can expand upon, because I think people are maybe in some audiences aren't used to thinking about that. So elaborate, and so that's our principles, which are, I use that term loosely, but it's and I'm just trying to update some of my thoughts on this, and I don't know what people are like. If people have comments, chime in if you think that there's something that's not clear here. All these concepts provide a means to create a differential system between motion, which is information, and random noise or stasis, which is non-information. This is maybe a little naive. There's a grounding theory in cognitive science that we could have talked about here, but I think we were limited by the size of the abstract in that submission. Grounding theory, whatever. Or I guess, so by applying this framework to a variety of specific contexts, including a 4-channel model, multisensory embodiment, we demonstrate how GI is essential to understanding the full scope of cognitive information processing. So at the beginning, we talk about the difference between, or maybe how Shannon information is thought of. There are all sorts of variants on this, like integrated information theory, and there's also this idea of Bayesian surprise, which is using information theory and a Bayesian model to characterize, if something has high information, I think it's surprising to people to see something. So if there's a system with high information, you'll often encounter surprises. And if it has low information, you don't. And the idea is that there's this prior, and then if the prior characterizes very little information, then your observation isn't going to be very surprising. They use that term surprise as sort of a, it sort of links to Shannon information, but it isn't. They don't call it that. And so that's, those are kinds of things you need to kind of frame this around. And then we're kind of departing from that in a number of ways. So I guess the idea here is that we have these 3 different sort of principles. We have this sort of set theoretic point here, which is disjoint distribution. We have this decomposition tree here, which is contingent action. And then we have this collective behavior mode, which is coherent movement. And so all those are really kind of, I guess some of these are, it's catching a lot of things that are superfluous in the text, but that's okay. So, these are all kind of leading to mathematical formulations. And so you can see here in this figure that this is related to Shannon mutual information. This is related maybe to something like swarm intelligence or swarm something. And then this is contingent action as a decomposition tree or a contingency tree. And so there's probably a mathematics behind that, but we don't lay it out in this paper. So I would been really wanting to dig into this and try to figure out what that looks like. And it may not even be a mathematical model. It could be just like a agent-based model, especially for coherent movement. But that's something that, needs to be worked out. So just little pieces here. So we didn't really have a lot on each of these. It was just kind of a summary. And we were limited by space. So if we can expand these out, that's an opportunity to do that and to really kind of lay out and maybe even have a methods section in here where there's some methods, maybe some equations, and then link them to this section where we kind of describe them. Then there's this part 4-channel embodiment. This is something that is something that was kind of put together for this paper, so it's not something that's been well worked out. We kind of use the developmental Bradenburg vehicle as maybe an example at the beginning, and then kind of move into this multisensory embodiment, and then there's this model here, 4-channel embodiment. So this is the metaphor that's being used. Okay, so you have this rabbit in this picture, and the rabbit's hopping around on the grass, and the rabbit is encountering things in the environment. It's a visual environment, but also the haptic environment, proprioceptive environment, and the auditory environment. So the rabbit has to find its way through the world, has to orient itself. So this is a very broad set of cognitive abilities. So it could be attention, it could be memory, learning and memory, it could be just motor control, all these things, and there's all this information coming in. But the important thing here isn't really the cognition or the cognitive mechanisms, it's the information coming in. So you have two things here. Each channel is a sensory channel, and then each one of these arrows is a form of perception. So this is direct perception, which is the black line, and then inferred perception is this dotted line, which is where you have something, for example, in proprioception, the rabbit is getting information to shift left. The auditory channel is giving it information about birds chirping, and you can localize that. The haptic channel is giving this information about forward momentum, but it's inferred perception. The rabbit can maybe see things moving forward, or is maybe planning to move forward. And then visual is forward motion. So that's direct perception. There's this movement of the animal, and there's a visual flow coming in. So all these channels kind of exist sort of semi-independently. These arrows, the direction of the arrows kind of tell what, maybe spatial direction it's coming from. And then that gives you some idea of whether it's congruent or incongruent. So if it's congruent, all these arrows point in the same direction. If it's incongruent, they point in different directions. And the incongruence, and this wasn't described very well in the paper, the incongruence is a problem for sort of unified perception because it's confusing, right? So it's like this Bayesian surprise idea. You're surprised by things with a lot of information, but a lot of information just means that it's something that you wouldn't expect. So there, maybe 4 or 5 different options instead of 2 options. That's surprising because you can't predict it every time. So this is kind of where this is going. This needs to be developed more, but I just wanted to give people an idea of what we were doing in this paper so that people can, maybe if they want to contribute, they have something to say about it, or maybe they think they can improve it, then I welcome, you can join in on this paper and get authorship, and, maybe we can develop this idea further. The abstract is due this week, but the paper itself can, we can go as far as we want. I don't know where it's going to end up going. We had talked at one time about submitting something to Collective Intelligence, which is a new journal, a newish journal, and that might be an option. But there are a lot of options for submitting this. It still needs, I think it's not yet a preprint. So, at some point it's going to become a preprint. And then at some point it's going to maybe be published. And that would be nice. I think this is a good idea. It just needs to be fleshed out more. So, There was something else I was going to say.
Hey, Bradley, can you hear me?
Yeah.
Sorry, I just was away for a bit. What was the thing about the journal that you're talking about?
Oh, okay. So I was talking about like submitting the Gibsonian Information paper to a journal. There's this journal called Collective Intelligence that's newish that we might try, but there are other options for submitting. So that's something that we have to figure. We still have to work on it. We need to get it out as a preprint first, of course, but yeah. So that's kind of a long-term thing too. So let's see. We have Jesse had some chat comments. Jesse, it can be updated. Yes. I was going to say I've been thinking about the different kind of segments of the cog-sci time. Some more computationally focused, some less. So this was what?
What's that?
This comment here. I've been thinking about the different kind of segments of the cog-sci time. Some more computationally focused, some less. What was that?
That was about the cog-sci discussion group.
Okay.
So that's from the past. But basically, I was just saying, I think it would be good to have, we need a place to discuss that.
Yeah. Yeah, I might actually create a channel in the Slack, an internal one. We could also use Anson's research channel. I don't know if that's
Yeah, that could be polling focus for this right now.
Yeah.
I think having there's an introspection, there can be a section for honestly, it would be super nice to get into the Cognition Features project and the Cognition Model surveys, and also obviously the state-of-the-art AI is kind of where I'm going with that. So that could be like a whole, I don't know, 20 or so. I think and then I think about what are the kind of installments we want to have in that section. So this is kind of been separate. I think at the start I was just
I can't hear you. It's very hard to hear. You could type it out in the chat, I guess. If worst comes to worst here. Yeah.
Yeah.
Because it's really, it's not. I know the train is really not. I know they have Wi-Fi, but it's not great. And then the phone service is often not great either. I don't know. Yeah, so there's which topics? So we had we'll have to come up with a topic list. That's good. And then you were saying that there's some more computationally focused. So we have the sort of the surveys or the map out all the stuff we want to cover. And then, like Jesse's doing this stuff with state of AI, state-of-the-art AI. More in Slack later. Yeah, so we have some computational topics, some less computational. We just need to come up, I think, with a list of topics or maybe focused things that people can do to focus direct activities. And I think we need a roadmap, which is, I guess, the correct term for that. So, we give people a roadmap and you say, well, you fill in each part of the roadmap with what you want to do. And this is actually, we can use something like Miro or even some of the other, Jamboard, one of these other ones where you can put in different boxes and you can kind of fill them in as you go. So you can say, this person expressed an interest in this area, just kind of really giving people a guided So people don't think, well, I'm interested, but I don't know what I want to do. Well, we'll talk about it later. Well, usually it doesn't really go very far. Like people, they can't latch on to anything. So yeah, we need to kind of get a series of sort of directions or topics into place, and then we can maybe give people potential ways to contribute. That's a good way to do it. And we can tie this in with state-of-the-art AI too. Like, I know you're trying to build a community there, and I'm not prepared today to talk about like community building, but one of the things you can do in community building is you want to raise awareness of what's going on. So you want to give like an overview of what you're trying to accomplish, how people can contribute. Sometimes if you have good first issues, that's good. Keeps people, sort of gives them something to get their, sink their teeth into, gives them something a little bit more concrete to do. And then from there, they can springboard to something more complex, but it also gives them the things they can, yeah.
I had a kind of like a general idea or question, and I don't know what you think about this. Just to kind of stop for a second, I can probably talk about it. I was considering not like a debate, but like something that would involve people trying to discuss some of the critiques that come from the what happened to cognitive science paper.
Right.
Does that make sense?
Yeah.
And it's saying what people think, like, hey, is cognitive science going in this direction, or is it becoming more unified or not, and where is it going? And just seeing what the people have to say about that, rather than it being like something we try to give an answer to, just seeing what people don't want to say about that, maybe.
Right. Yeah, that's true, because we're going to have people from the CogSci conference. I was going to say maybe we could invite, since people are going to be there, maybe even invite Nunez to come and give a little thing about it. But I don't, that often doesn't work so well because people have a lot to do. But I mean, we could ask people if they want to be in, people from that debate, if they want to be involved. They'll probably be at the conference.
Yeah, that's true. I think definitely, I haven't even thought about inviting people specific for that, but we should look into that for sure.
Yeah. Even if it's just another, what I did for the one I did 10 years ago was I interviewed some people via email. And I just presented the interviews in the session. So it was I asked them about this topic, and this is what they had to say. And it was it was about things that this session I was organizing was, it was about things that are hard to sort of define in science. So it's what in your area is hard to define. You can find examples. And of course it was a wide range of people, so it was different things. And so, just getting their impressions about it. So you could actually ask people, yeah.
Abby, that's one of my ideas for my next project.
What is that?
I was just saying that was one of my ideas this week or last week for my next project in ethics. I was thinking that'd be kind of a neat thing to include because I found someone who's working on it, and I thought, well, I could interview them as part of the information gathering. So, yay!
Yeah.
Yeah. And what were you referring to specifically, Erin?
Well, one of the projects that we were talking about, either the one based on sort of colonialism or the one that was based on sort of ethics and the way that we're building the next tech. There was someone that I'll get you more information for it afterwards.
I remember now who you kind of mentioned. Okay, yeah. Okay.
Yeah, and the benefit of that is you get sort of a more candid take on it. They publish what they can publish, but they probably have some more candid takes that don't make it into the paper. So that's a benefit of that. And but in the ethics case, I would definitely like make sure that you get clearance, like tell them what you're doing, because that's But
oh yeah, human research definitely.
right. But yeah, those are good to use, and like yeah. So I mean, we so there's so much here. There's so much opportunity to get sort of to get some really good content and to get people thinking about this topic. So yeah.
Another one of my ideas related to this was kind of copying what happened at the AI workshop, and basically having maybe not like a podcast, but like if people want to have an informal like say on a certain topic, like we could ask them for that kind of involvement too. That was kind of like they had like a couple questions for us to answer, and like after outside the event. So I'm not saying that's exactly what we should do. I just wanted to keep in mind as another option.
Yeah, I mean, I think we can even expand this outside of the scope of the discussion group. Like, we can have like maybe interviews or something where we give them a little bit of time to, reflect on it and, post things like, like have a media channel where we kind of, this is this person's take on this or this person's take on that, and I would focus it. Well, I mean, they can give their own take, but I would, try to hopefully it's focused a little bit on maybe some specific thing, like the debate, the cogs, what is cogsi or what's the future or whatever. I think those are very good to kind of address, and that's that's something that you can then archive and people can use it as a research tool, as a sort of a looking back tool, retrospective. So in 5 years we can come back and say, oh yeah, there's this thing that we need to address or follow up on. That was an epically bad take, or that was pretty prescient. That's what's going to happen with a lot of the machine learning stuff. Is like, it's even happening now. People were taking like 10 years ago, there were takes that are probably not aged well. So
did you see? To speak a little bit better, did you see that tweet by Conrad this week that basically looked at he was basically questioning like, is this where's deep learning going kind of a thing? Like, deep learning isn't trending as much anymore. Did you see that tweet?
Oh, about the sort of the bibliometrics of deep learning, or the Google trends on deep learning.
Yeah, it was like it starting to dip a little bit in the interest or something like that.
Yeah, I mean, well, the problem with Google Trends is like it's not. It's like you mention something a certain number of times, and it's like, is that due to there being a lot of hype around it? Or is it because people were less interested? Or is it that deep learning was, like, 10 years ago just called deep learning, but now is, like, a bunch of things that are, specialized terms?
Yeah.
That, so that's yeah. But, you can, and I think people remember this from previous meetings. We've talked about the Gartner hype cycles, where you have these, these sort of things that are emerging technologies, and then they hit this period of high hype where, like, everyone's talking about them and they think it has unlimited potential. And then finally there's this crash and it's inflated expectations, and then there's this subsequent crash that's basically where people say, well, this didn't really work out, or, I'm going to go do something else. And then after that, the thing takes back off, ideally, into this plateau of productivity. So, I mean, maybe we're kind of on the back end of that hype cycle with deep learning. It's starting to be applied to things.
Yeah.
Right. So, that's interesting. I definitely think that there's a lot to... Like, in these, I think there's, like, actually, I don't know if I put it in the Slack, but there's a Gartner hype curve for, I think, for machine learning and deep learning that is pretty recent. And there's a lot of interesting things on there. It's it's totally a subjective evaluation. They don't have like metrics that they're using. They're just kind of like putting it on this curve, but they're like all these specialized technologies that are, on the curve at different points. So I think deep learning is a generic term. I don't know what maybe the trend is moving away from, this sort of inflated expectations. But so I wanted to, thanks for that conversation. I wanted to go back to the Gibsonian information. I wanted to put the document link in the chat. So this is I don't know if people are interested in doing this, but you're welcome to contribute to this document. If you want to leave comments, we can address them. So this was submitted to the CogSci conference, the same one we're presenting this discussion group to, and it was rejected from there because their acceptance rate is like 30%. So I didn't expect it to get accepted, but it's something that I just wanted to get some feedback on. I didn't really get the feedback I was looking for, but I think it's always a good thing to like write something and put it away, and then maybe in a couple months go back to it and look and see what it looks like to you. And as you can see, it's like, okay, it's not maybe what I thought it was, which is fine. That's normal. Let me go back to sharing my screen. See, Erin had to leave. So thank you for attending, Erin. Go back to this Gibsonian information thing. So that's the paper. And
I'm still here.
Oh, you are? Okay, good. Thank you. Oh, maybe Jesse got cut off. But okay. Thank you for being here. So we presented on this in a number of, like the EI workshop, there were some slides on Gibsonian information, and been kind of mulling it over more recently. So this is something that's going to be kind of coming up in the next few months. I don't think there's anything in this. I do have an overview here. And this is the meme I created for it here. It's like, this is Shannon information. This is Claude Shannon on a unicycle, and this is J.J. Gibson. But this is the 4-channel embodiment idea, follow the white rabbit. So this rabbit is hopping, and we have these 4 sensory channels. They're kind of moving around. This was kind of a animation, just kind of like showing the common, the coherent movement across these different channels that they're moving kind of together. And then this kind of lays out what I was talking about earlier. Congruence versus incongruence is the idea here. And then this is the diagram. One more word about this diagram is that it's meant to be like this sort of symbolic language. So we've talked about symbolic languages. Basically, you have these channels, discrete channels. You have information flowing through them in different directions. And then, it's either inferred or direct. So it's either like, something that is in this time period or something you're inferring from past time periods. So, that does imply maybe a Bayesian model, but it doesn't have to be a Bayesian model. But that's basically a breakdown of that idea. And I think that's like a centerpiece idea. And I don't know how to take that from here, but that's something we're working on. Another kind of curiosity I'm going to point to here is something that I've always been interested in. And this is, I don't know if you're familiar with board games. I know that a lot of you are familiar with Monopoly and with Scrabble. But I don't know if you knew this, but if you look at the Monopoly board and you look at the Scrabble tiles, you notice that they kind of hit this top limit of information. For example, if you analyze the Monopoly board, and then someone did, I don't know where I got this from, but I found this. Let me see if I can rotate it. Well, it doesn't really matter. You can see this is a Monopoly board, and you can see these different colors. These are the different streets that you visit. This Monopoly originally was based on Atlantic City, New Jersey, and it has the different streets, and you roll dice and you go to these different spots on the board. And this basically is a distribution of visitation rates of all of these different locations on the board. So excluding the corners, you get these probabilities, or these probabilities of visiting a certain color or a certain street. And so if you break these down, you find out that there's something called maximum information, which is maximum Shannon information, which is like if everything had an equal probability across my set of like things that I'm measuring, that would be maximum information, because you have an equal probability of doing anything, visiting any place. If it's like if there's only one place you can visit on the entire board, then this would be 1.0 and all of these would be 0. And that would be minimal information. There's only one thing I can predict now, and I can predict in 100 years where you'll land, because there's only one place you can land. And so this is the idea, you have maximal information, you have minimal information. The way this board is set up is that it's very close to maximal information. Not quite to maximal information, but it's very close. And I did the calculations on this, and I found that to be true. I confirmed that. I have them in this numbers file, which is useless in Google Drive. But so that's the Monopoly board. Interestingly enough, and I know this from a couple decades ago where I did this analysis, just kind of off the cuff, just out of curiosity. If you go to Scrabble and you play the game Scrabble, which you have a bunch of tiles of letters on them, and the letters you put them together to make words, but you have this bag of tiles, and if you look at the bag of tiles, the letters that are available in that bag are distributed according to their frequency in the English language, so much so that it's actually close to maximum information. So in other words, people have taken, like the people who designed Scrabble, I don't know if they did this purposefully or not, but they have a frequency of letters in the bag. So for example, there's 1X maybe, and like 5 P's and 10 A's, and the distribution of those frequency of tiles is actually very close to maximal Shannon information. So someone pointed this out on this board and card game Stack Exchange. In Scrabble, each letter is worth a number of points. Typically, the rarer the letter, the more score it has, which is also the number of letters that are in the bag of that letter. Does anyone know how these scores are assigned? It's actually assigned on the frequency of the letters, but that's also related to this proportional to surprisal, which is this thing, self-information from information theory, which is this log 1 over p, which is a sort of a derivative of Shannon information. And so someone else is pointing this out. And this is, I don't know if this is just like an intuitive thing or what. It might be intuitive, it might be something that people used, I don't know. But it's interesting that outcome exists. So, that was just an aside on information theory. I thought you'd enjoy that. Now, I want to ask people if they have any comments or questions or thoughts before I move on to the papers. Okay. All right. Well, if there are any questions you have or comments, you can put them in the chat, or we can talk about them on Slack after the meeting. Okay, Jesse's back. Hey, Jesse. So let me go back, sharing my screen. And we have a lot of things here in the paper file thing here. Let's see where it is. Here it is. So we have a lot. I didn't know what to present today. I was thinking of presenting a couple things. I had this thing on Gibsonian information and synthetic cultures, but I'm not quite, those slides aren't in decent shape yet to present. But like I said, we'll probably be talking about that in the near future. There's also this theory building in data science, which actually I might do. I might do this, go through this talk. This is something that has been around for a while. I first did this in 2018, And I'm kind of hoping that this is something that we can maybe expand or update in the near future. I think maybe people will find it useful. It might not be, well, it might be useful to the ethics team. It might not, but so this is the idea of theory building for data science or for big data or for machine learning, deep learning. So this talks a lot about like naive theories, and something called content-oriented models, and getting theories from data. So it starts out with an article back in 2008 in Wired. It was called "The End of Theory," and if you want a little piece of advice, if you write anything and give it a title, don't call it "The End of X," because that's always wrong. Like there was a book, "The End of History and the Last Man," back in the 90s, and clearly that was wrong, right? This was also wrong because, yeah. So, I mean, that was the way people were thinking back in 2008, that there was all this data that was coming into the system, and it was going to swamp out everything in the world, scientific method, etc. As it turns out, it did not. And the reason it did not is because we have these things, well, one reason is because we have these things called spurious correlations. And there's this site called Spurious Correlations, Tyler Vigen, who put these together. And so one example is this correlation of total revenue generated by arcades with computer science doctorates awarded in the U.S. You can see they track pretty closely, right? But then, of course, that's because they're not related. It's just because they have the same trend. I mean, so one could argue that if you took those two variables and you had no theory underlying it, why they should relate to one another, you could make that correlation. You could make the argument, rather ridiculously, that arcades and like people were earning doctorates in computer science and they're, going to the arcade and they're spending money, which, isn't like that's absurd, but you could make that argument, right? So I guess why do we need theories, aside from that self-obviating example? Theory allows us to comprehend patterns in the data, propose candidate mechanisms for data generation, and infer missing components of the system that generates data. So there are a couple of traditional views of how data is organized and the relationships between data. The first is to describe data as a function, and that's this general linear model idea of taking an independent variable which you manipulate and then measuring the dependent variable. So there's this independent variable here. If it varies, it affects the the dependent variable, and you can get there's maybe a trend line or something else. That's one view of doing this. Another view is, of course, that we can describe data as a function, but there's also causality, and that's a separate thing. I know there's a lot of talk about causality, and people oftentimes assume that when you have a linear model and you have this relationship that it's causal, but that's not true. It's a different thing, they're different criterion, and so theory helps us to sort of tease that out in some ways. There's a lot of work on causality in and of itself, but I think theory does help you think about at least making that distinction. And then you have these multivariate models, which are very similar to the general linear model, but you have these two variables having an effect on a single dependent variable. So you're manipulating two variables, you're measuring one variable. And one way to do that is to take like a principal component of the inputs of the independent variables and put it against a dependent variable that varies. So your PC1 will be manipulated, and then that's sort of a lower dimensional projection of a lot of these independent variables that are all being manipulated and then against the DV. So that's another way to think about relative contribution of different variables coming into the system. So, when you talk about the effect of different genes on behavior or different genes on a phenotype, you often have many, many variables, and they all have relative contribution, sometimes very little contribution, but we want to know what those are. We also have sort of the components of variance. So, again, you have this model where you decompose things into a principal component, and you want to know, like, what are the components of variance? you have the variables, but maybe there are different components of variance that, we can use to build like constructs. Like, maybe there's some component of variance that's, left, right, maybe there's one that's up and down. And so those are two separate things coming from the same set of variables. It's very important to know kind of what to make those distinctions. And then finally, you have interacting variables, which are where sort of like a network view. So now you don't have a linear model at all. It's very nonlinear. You have all these inputs, and they're all kind of configured, interacting, and they all come to an output. And so now the question is like, what is the effect here? It's not really going to make any sense. But you can get, input is now a manipulable property of the network. And so, but you want to be able to understand all these things. You can also have a generative setup where the output is a generative property. So all these things are important to understand and to differentiate between. Now shifting gears a little bit, Clyde H. Coombs, who was a psychologist, proposed a theory of data, and this was back in, I think, the 1960s. So, psychologists were working with data, and they were, a lot of psychology departments do a lot of data and have a lot of data analysis courses, but, and methods courses. So his idea was that there's a theory of data, and his idea was that there's this, we have to have a formal method for collecting and analyzing data. This is sort of like, before like meta science and all this, so this is kind of like formative in that aspect. You have something. Of course, there was psychophysics at the time, which was a sort of a model where you would have an input to the perceptual system, and the perceptual system was characterized by some equation that told you, like, if you vary the perceptual input, what's the output going to be? And it was usually some sort of mathematical function. So he came up with this idea of content-oriented models, or multidimensional psychophysics. And this cast in mathematical form these sort of miniature behavior theories. So this was related to the psychophysics idea, where you have these short equations that describe movement. It could be like the Fitts law, or it could be like the Weber-Fechner law, which have to do with different, like moving an object, or seeing why, things of a different intensity and responding to them. They can all be described mathematically. So, but the important thing to extract here is that you have these little miniature theories, or these mini theories that come out of mathematical equations and like little things, and they describe a larger form. So the mathematical equation isn't, yeah.
I have a question about that. This is a bit of a tangent. I don't know anything about psychophysics really.
Yeah.
Well, like, did you ever hear the term or phrase like information metabolism in that discussion of that thing?
I'm not sure. I don't think so.
Okay, it's related to something very, very different. But I was just curious. More about that later, but that's important to know.
That's fine. Yeah, I don't know that term, but so I mean, I guess the point here is that you have these equations, but they're not enough in and of themselves. They're just these little mini theories, and you'll see how those kind of work later. It allows us to formulate hypotheses and theories, alternative hypotheses, but it's not enough in and of itself to interpret the data. So here's a content-oriented model. This is called Fechner's law. So the idea here is that you have you have 4 arrays here, and you have 2 arrays that are compared. Like, so you have the one on the left, the top and the bottom, the one on the right, the top and the bottom. The one on the left, the top and the bottom, is the difference between 10 dots and 20 dots. And usually when you show people this, they can differentiate quickly between the two. You can see that there are more dots in the 20 case than in the 10 case. In the second one, you have the difference between 110 dots and 120 dots. And again, this is something that's harder to do. It's harder to distinguish that. And we don't really know why that is. It may be because people aren't counting the number of dots. That much we know. But aside from that, is it like, are they noticing the patterns? Are they noticing maybe the densities? It's not really clear, but what we know is that there's this just noticeable difference where you can get to compare 2 arrays, maybe, with very, very few dots or maybe a lot of dots, and you can get these differences. So people are looking at these arrays and they can make these distinctions. And that can be described with a very simple equation. So you can use an equation to describe visual perceptual data, just noticeable differences in stimulus magnitude changes. So we don't know why exactly that works. We kind of do, but we don't really know, like, cross-culturally, or like if, what exactly is going on. We know, though, however, that it works and that there's this equation, at least in the literature that exists. So, we can use this equation, and it's a varying utility. It doesn't describe the data perfectly, but it's something we can use as a shorthand for some mechanism. So in a theory of data, the theoretical model should bring us closer to recovering the true phenomenological space. This is generally true under two conditions. If the phenomenon is law-like, so in the case of the Weber-Fechner model, we have this, we assume that there's a law or a regularity in perception, in the perceptual machinery in the brain, but we don't know what it is necessarily. That's one thing, and it may not be true. Maybe we stumbled upon something that's maybe something doesn't require a lot of secondary processing. But also, if data provides a direct or inferential window to a phenomenon. So if the data is really kind of something central to the mechanism, or if it's just kind of a measure that doesn't have a lot to do with the mechanism. Those are those are things that you have to think about. So another thing from the past that I'll bring into this is a grammar of graphics by Leland Wilkinson. Now, he was a data scientist, and he also had sort of had a theory of data. And this theory of data had two views on data. One is that data can either be realist or a realist view. So that means that data represents indirectly observed processes or phenomena. So that could mean that, biological evolution, collective behavior, exoplanet detection. We don't actually have direct observations of those processes. We just use indirect proxies or measurements to get at that process. And they work fairly well, but we don't actually have a direct measurement of it. And then the second is nominalist. So in that view, data represents whatever they describe. So the data, it's basically the color and shape of rocks, it's DNA nucleotide sequence. We're measuring directly from the object, and we're getting this information. We don't have to do any sort of inference. We don't have to assume that this is, something that is occurring as a process. That being said, realism actually works quite well. It's not so much that it doesn't work, it's just something we need to make the distinction of. So we can think of abstractions as many theoretical models. We have these data functions used to arrange data elements, and we end up with this n by n array, which is the structure, or something like a third-order polynomial, which is a tendency. So it's like a function, which is a tendency, versus some sort of array, which is a structure. And then this leads us to Tucker's theory of abstract data types, where mathematical models are defined by the user. The model has a level of computability, and it has a level of behavioral completeness. So there are a lot of considerations in these different mathematical representations of data that people have kind of thought about and come up with different ways in which to think about all the different aspects of these types of data. But so far, we have three ways to get to a mini-theory. The first is content-oriented, which assumes this regularity of data points. So we can use these mathematical equations to sort of infer laws or conditions. We have measurements, which are these, different ways to measure things. You can have comparisons that are all-to-all or pairwise or whatever, and we have that. And then we have abstraction, which is a combination of 1 and 2. So, abstraction is where you maybe measure something indirectly. You also have a content-oriented model that describes the relationship between that measurement and some mechanism in the world. And this is how we do this. This is how we build a mini-theory. So mini-theories are also sense-making models. And now I've been talking about a lot of sort of detail, with respect to data, but now we can, and this is, I like this is zeros and ones going into a machine. There's this mini theory, and it churns out this classification. It's supposed to be a black box. So mini theories can also create sense-making models of the world. We don't necessarily know how to make sense of this, even though we know how to, say, build a mini theory, how to give a little mathematical description of the phenomenon. Do mini theories create a dream of electric sheep? And so you can see that cloud of zeros and ones, you can see a sheep in there. And that's, that's an interpretation, but it's also something that we can build that's one of the reasons we use theories, is to find things like that, or to maybe refine our vision of it, maybe test to see if it's actually the case or not, because we can come up with a lot of potential descriptions of what's going on with the data, but we need to confirm them as well. So then there's this, so data-driven science is a failure of imagination. So this is more critique on the data-driven science idea. And this goes to Bayesian models. And Bayesian models, of course, are conditional probabilistic statements as in the form of a generalized hypothesis test, or at least that's the way that this person defines Bayesian models. This is theory given data. This is consistent with a theoretical but naive view of the world, and more data makes it harder to test simple theories using this. From this same reference, we also find that there are a number of linear regression model scenarios where you have a sample, you take a sample size, you have some effect of a positive statistical test, and then you get support for a theoretical model. What's interesting, and maybe you've seen things like this on the internet, I think I saw a GIF on this a while back, where you have these different classes of, given a certain amount of input data and using a model to predict it, you have different types of support, or, given the sample size or the distribution of the data points, you have different forms of strong and weak effect and strong and weak support. So it classifies these in these different ways. There are also, cases where you have, different sort of inputs and outputs, and you have different organizations of data in a bivariate graph, and it has very different results. So, they're just putting things in a graph and putting things into a linear model may not actually give you what you want. So we have to turn to something called naive theories. And naive theories are theories that people just kind of come up with on the fly. They're not really that informed. Sometimes they're woefully wrong, such as the extramission theory of vision, transformational theory of evolution. Both of these were before vision science and before Darwinian evolution. This is the way people thought of these domains, and they were intuitive, but they were wrong. And so even when you have an intuitive idea of how to interpret the data, they can often be wrong. And so naive theory is formalized sense-making, but you have to be careful that you're not drawing from your own biases, drawing from your own sort of what you think is common sense, because that can often be wrong. And so, and you can see Einstein shows that theories are a subset of common knowledge and don't necessarily substitute for them. And then I have this thing about Innavitous models, which are what is plausible given no formal theory beyond naive Bayes. And I kind of go through some points here. Epistemological models, equation-free models. What is intuitive given a set of correlations and limited causal information? And I've been working on this Innavitous Models idea for a while. Never really gotten very far in it, but it's this idea of using plausibility in place of maybe a theory. And then a topological way to view data in theory. So you have these mini theories, which are equations. You have the observed data, and this is the amount of data that can be explained by the mini theory. So you have to think about this in terms of like a nested set or an overlapping, the overlap between two sets. It isn't necessarily true that your mini theory will explain your data completely. You have to make that distinction. Then you also have this, you have this subset of the data that can be explained. And then you have, sometimes you can have different sub-theories or different, like mini-theories that cover different parts of the data. So you can have these mini theories as patches over different parts of the data set, at the data space. And you can take those together to describe a significant portion of the data. The problem, of course, is that they need to be consistent. And so that's another way to approach this. So the relationship here between multiple subtheories in the data, in this diagram we have 11 possible sets of relationships between subtheories in the data. So we have these overlaps between subtheories in the data, and then subtheory and data do not overlap. And so that's in this area, which is under specification. The overlap between subtheories and data is the explanatory power, and between subtheories is the covariance. And so this is just one way to break all of this down. And so I don't know how many more slides I have. Oh, I have one more slide. Okay, so then we have this idea of theory and meta-theory. So there are these mathematical discovery tools that allow us to discover like hypotheses and axioms and other types of things, and that allows us to build meta-theories, or theories on top of theories. And so you can get pretty complex here. The idea is you can sort of decompose a system by building these theories on top of one another. And so, this is just another way of saying that, that this cartoon is true. And this person at the left here says, this is your machine learning system. The person on top of this pile says, yep, you pour the data into this big pile of linear algebra, then collect the answers on the other side. This person over here says, what if the answers are wrong? The person on top of the pile says, just stir the pile until they start looking right. So hopefully, we can avoid that in the future. But that's basically, this is something that's a couple years old, so it needs to be updated. But that's basically, I think, a pretty good view of things, because I don't think people think about that too much. Okay, so yeah, good. Angela says, good point. The end of the ends, if only. And then Erin says, I have to catch the YouTube for the remainder. Thank you. Well, thank you, Erin, for attending. So yeah, that's good. Are there any other thoughts about that?
I don't know if you can hear me, but just saying, oh, it sounds pretty cool.
Yeah. Yeah. So, again, I said I don't know if this is relevant. Well, it's probably somewhat relevant to the ethics in society, but it's something we can draw from. I figured I'd present it. So why don't I get onto the papers? We have about 15 minutes left, and we started a little bit late, so I'll do a couple papers, and then we can wrap up for today. So let's see. Okay, so let me go back. So there are a couple of papers here. I didn't want to get too deeply into a theme here, but this is one thing that I found. This is Meta-Theorist. This is a discussion called "Are We Building on Air Castles?" So I told you about theory, and people have these contentious fights about theory and the role of theory. So in this case, they hosted a paper discussion on this thing called the theory of before the test. This is something, I think this is Iris von Ruy, who we had one of her papers earlier. I don't think it was this one though, that I co-authored with Baggio. The meeting was part of a reproducibility journal club series hosted by these people. So this was a discussion about this. Actually, this is interesting because this is about theory building in cognitive science. So the question is what do we do now in cognitive science? Are we all building on air castles? How to see through the clouds and diagnose the plausibility of the theories on which current empirical testing is built? Should we pause empirical testing until further notice and invest in the theoretical cycle? So the argument here is that, in fact, it's not about the non-utility of theory. It's actually a very similar thing to what that presentation was about. Is that we're doing all this empirical work, and our understanding is kind of based on that, but very little theory. So we're just kind of interpreting our empirical work. But is this building on air castles, which are these things that are kind of suspended in the air? Maybe we need more theory development. And this is, of course, a question people ask all the time. I think neuroscientists ask the same question. So they have a bunch of things, and this is actually cognitive science oriented. So this might be an interesting thing to think about for the event as well. What should cognitive science do now? Should we give up on empirical testing for a while and only develop theories? Well, that's a sort of a straw man question, but the idea is to elicit some response here. I think this disbalance is not doing cognitive science a service. It reduces pluralism in approaches and undercuts the theoretical research that it does exist. What is needed to enact change? We need a change in culture. So chapters and PhD theses are typically expected to report on experimental work, but maybe give an opportunity for theoretical development. We need a change in education. Theoretical research requires a different set of tools. We need to teach those tools. As you could see from what I was talking about in the last talk, there's a lot of stuff that we could bring to bear here to think about it. We also need a little more time for thinking. And if I want to develop formal theory in my own line of research, where do I start? So you can, there are papers like this one, Formalizing Verbal Theories, a tutorial by Dialogue. This is how you would formalize a verbal theory. You can use fictive characters. You can use mathematical equations. There are a lot of ways you can do this. And then, is there harm in doing experiments without clear theoretical predictions? There can be great value in that. So Einstein was well known for his thought experiments, which are useful even in the era of computation. So this is good. This is a nice thing. You can read this at your leisure. I'll send the link to the. Let me put it in the chat. So this is the drive here. So you can go into the drive and the papers are in there. Okay, so the next thing I wanted to talk about was this radical embodiment in two directions. This is newly published in Synthese, which is a philosophical journal. This is Anthony Camaro and Edward Baggs. So something I think Jesse and Anson would be really interested in. So the abstract is radical embodied cognitive science is split into two camps, the ecological approach and the enactive approach. And we've talked about those in last meeting and this meeting. We propose that these two approaches can be brought together in a productive synthesis. The key is to recognize that the two approaches are pursuing different but complementary types of explanation. Both approaches seek to explain behavior in terms of the animal-environment relation, but they start at opposite ends. Ecological psychologists pursue an ontological strategy. They begin by describing the habitat of the species, and using this to explain how action possibilities are constrained for individual actors. So they have this naturalist view of the world where you're in this natural environment, not an experimental environment, and then you have to use that to explain the possibilities of action. Enactivists, meanwhile, pursue an epistemic strategy. Start by characterizing the exploratory self-regulating behavior of the individual organism, and use this to understand that the organism brings forth its animal-specific Umwelt, which is a German term, I guess, meaning mind and body. And so there's this term that we need to clearly define here. But that's a theoretical construct, by the way. Both types of explanation are necessary. The ontological strategy explains how structure in the environment constrains how the world can appear to an individual, while the epistemic strategy explains how the world can appear differently to different members of the same species, relative to their skills, abilities, and histories. Making the distinction between species habitat and animal-specific Umwelt allows us to understand the environment in realist terms, while acknowledging that individual living organisms are phenomenal beings, in phenomenal meaning like that they engage with phenomena, like mental phenomena, physical phenomena, not that they're great beings. So that's so they kind of go through this, and they kind of go through this difference, and they kind of try to unite this. So last week we had a paper on, it was the Adam Safran paper, was it, on the difference between there was an attack on ecological psychology by the interface theory people, and so there was this sort of debate about that, and he was defending ecological psychology. In this case, we're defending, I don't know if we're defending ecological psychology, but we're contrasting ecological psychology with enactivism. And so this is a nice, another good example of this, where we have this sort of debate between two approaches. And so the deep contrast between these two approaches is well illustrated in a remark by Varela, Thompson, and Roche in their classic The Embodied Mind. The authors specifically distanced their approach from the ecological psychology approach because the latter assumes that animals live in a pre-given world. And so, thus the resulting research strategies are also fundamentally different. Gibsonians treat perception in largely optical, albeit ecological terms, and so attempt to build up the theory of perception almost entirely from the environment. Our approach, however, proceeds by specifying the sensory motor patterns that enable action to be perceptually guided, and so we build up the theory of perception from the structural coupling of the animal. So this is where you have this umwelt, where you have the body and the mind, and they're all working together, and there's this internal representation as opposed to just something that's out in the environment, and where perception is direct, and there's no sort of representation within to deal with it. So these things, but these are, you could see how these are, you could unify these two approaches. It's just a matter of kind of thinking about. So they say, we believe that these decades-old texts set up an unfortunate paucity of contact between ecological psychology and enactivism. This is primarily an educational phenomenon. Ecological psychologists read Svensson and Turvey in graduate school and think that enactivists are idealists who neglect the world. Enactivists read Varela et al. In graduate school and think that the ecological psychologists are realists, then neglect experience. So they're trying to reunite these two views, and I don't know why it's, I don't know if those two groups of people exist. I think probably people read them. It's just a matter of thinking that one is better than the other for whatever reason. I don't think it's because you only read one literature or the other. But yeah, this is a good paper, and this goes into Gibson's theory of affordances. So, that's an important part of this as well. And so they kind of deal with this issue of affordances. I don't know if there are any juicy quotes in here. So I don't see anything really juicy. But I think we'll put that aside for now. And again, this is something we can come back to. And I would reference the conversation we had last week on the paper talking about ecological psychology and interface theory to kind of couple with that paper. Okay, and so this final paper I'm going to cover today is this deep ethology of a virtual rodent, or deep neuroethology of a virtual rodent. So ethology refers to the animal behavior, or the observation of animal behavior. And neuroethology is thinking about animal behavior, but also considering the brain. And so this is a really interesting paper because they look at a virtual rodent, which they're simulating a rodent, and they're going to look at the neuroethology. So the abstract reads, parallel developments in neuroscience and deep learning have led to mutually productive exchanges, pushing our understanding of real and artificial neural networks and sensory and cognitive systems. However, this interaction between fields is less developed in the study of motor control. In this work, we develop a virtual rodent as a platform for the grounded study of motor activity and artificial models of embodied control. So this is where you have a neural network, but also a body that's sort of interacting with the environment. We then use this platform to study motor activity across contexts by training a model to solve 4 complex tasks. Using methods familiar to neuroscientists, we describe the behavioral representations and algorithms employed by different layers of the network, using a neuroethological approach to characterize motor activity relevant to the rodent's behavior and goals. We find that the model uses 2 classes of representations, which respectively encode the task-specific behavioral strategies and task-invariant behavioral kinematics, or the movement of the animal. So they're behaving, they have these strategies for behavior, which are task specific, and then they have these behavioral movements or kinematics, which are task invariant. These representations are reflected in the sequential activity and population dynamics of neural subpopulations. Overall, the virtual rodent facilitates grounded collaborations between deep reinforcement learning and motor neuroscience. So they're sort of laying out what they're finding here in these in this virtual model, and then they're calling for some sort of collaboration between deep reinforcement learning and motor neuroscience. And so I'm trying to see if there are any images here. So this is virtual rodent body. This is the anatomical skeleton of a rodent, as reference, not part of physical simulation. So they didn't actually simulate this, as far as I know. This is what the body looks like. The body designed around the skeleton to match the anatomy and model collisions with the environment. So this is that's what they're using. And then this is the virtual rodent doing tasks. So this is the rodent here that's like doing all sorts of behaviors in this space. So the visualizations of the 4 tasks the virtual rodent was trained to solve. A, jumping over gaps run. Foraging in a maze forage. So this is gaps run, where they have to jump over gaps. B is where they have to forage in this maze and find things. C is escaping from a hilly region or a bowl escape. So this is where they're going out and trying to escape through this maze of elevation. And then D, touching a ball twice with the forepaw with a precise timing interval between touches. So this is like this interval timing where they have to tap the ball and learn how to tap it in a way that's precise. So they have to coordinate their movements. Then there's this training a multitask policy. So they have this vision encoder and encoder, which is proprioception. This goes to a core module. This goes to a policy module. So they're using reinforcement learning for these tasks. So emboldened by recent results in which end-to-end reinforcement learning produces a single trained adaptive policy, we trained a single architecture on the multiple motor control reliant tasks. To train a single policy to perform all 4 tasks, we used an NPALA style setup for actor-critic deep reinforcement learning. So I don't know exactly what that is, but so they use this reinforcement learning analysis, and then they use, here are your graphs of what they're doing here. So this is the ethology of a virtual rodent. So this is an example of example jumping sequence in gaps, run task with a representative subset of recorded behavioral features. So this is where they're jumping over these gaps, and this is where they have all the different positions on the body, the kinematic markers, and they have virtual kinematic markers, and this is sort of the sort of time course or trace that results from this. The next thing is they have this TSNE, which is a method that I've talked about in my other group, but it's basically a way to reduce the dimensionality of the data. And this is what they call a TSNE embedding of 60 behavioral features describing the pose and kinematics of the virtual rodent. So we can identify behaviors in these little clusters. Although I think there's a definition of what there are definitions of what a cluster is in TSNE, but the point is that these things group together in certain ways. So you can see galloping, leaping, jumping, climbing, stumbling, spinning. They all kind of have their own little blotches in here, and so that's they're separable in that way, I think. So then you have these other things that they pull out in C, which are the first two principal components of different behavioral features, reveals that behaviors are more shared across tasks at short time scales, fast kinematics, but no longer at slow kinematic time scales. And so things that are shared at fast time scales sort of are disassociated at slower time scales. So the idea is to show that different time scales matter. And then finally, they have this representational structure of this rodent's neural network, where they show these similarity matrices, where they show these kinematic features here, and then different reinforcement learning policies here, and they show the results. So this is something that, if you're interested, I know that Rashab is interested, for example, in reinforcement learning quite a bit. He might want to check this paper out and like really dig into it and see what they're, if he thinks it's a good method for doing this or not, or if it can be improved upon. So yeah, there's a lot of good stuff in this paper, and I don't know too much more about like how to evaluate this, other than to say that there's, I think, a lot of like, sort of implications of this work. So, again, they're looking to sort of get this sort of dialogue going between reinforcement learning and motor control. But beyond validation, our analysis provides several insights into how these objectives are reached. Our essay revealed that the cell activity of core and policy layers have greater similarity with behavioral and postural features than with short timescale actuators. This suggests the representation of behavior is useful in the moment-to-moment production of motor actions in artificial control, a model that has previously been proposed in biological action selection in motor control. These behavioral representations are more consistent across tasks in the policy than in the core, suggesting that task context and value activity in the core engage task-specific behavioral strategies through the reuse of shared motor activity in the policy. So that means that they're sharing certain aspects of these behaviors in different ways across tasks and within tasks. That's reminiscent of sort of a biological, at least what we're thinking about theoretically in terms of biology and motor control. So this is I think, again, if you're interested in reinforcement learning, that's a good paper to revisit. It looks like we, let's see, I think Angela had to leave. Let me see what the chat looks like. Okay, yeah. So thank you for attending, Angela. Jesse says nice with the Camaro paper. And that's good. So is there anything we wanted to say about those papers or mention before we go?
I don't have anything to say, but it's just good to see the papers, and I started putting a couple things in the Slack because I think it'll be good to really start putting a roadmap together for the discussion at Cognition. So, but that's all for me.
Okay, that sounds good.
I'm almost in New York City now, so
okay.
Things are moving forward.
All right. Well, good luck with your travels. And yeah, hopefully, well, next week you'll probably be in England, and you're going to be in quarantine or something like that, right?
Yep, and I'll be enjoying every moment of it because, I don't have to go anywhere. I don't have to plan anything. I can just sit in one spot. It'll be great.
Very good. Anything you want to say, Anusha, before we go? Okay. Yeah. Well, thanks for attending. And next week, I guess we'll be talking. I don't know what we're going to talk about next week, but if you have anything you want to present, you can bring it to the meeting or post it on Slack, and maybe we'll talk about it during the Slack review. It's always a good time to talk about these things. And
yeah, I think there's a chance that Erin's going to have something to present next week because we've kind of had some things going, but she's on the verge of some stuff, so that's good. And Anusha might as well. I'll talk more about that during this week.
Okay. Yeah, why don't we make a point to revisit the critical period stuff next week and see where we are. I know that Angela was talking about it a bit in Slack. I don't know where she is, though. We'll just talk about it informally. We don't need to prepare anything for it. But, just to see where we are.
Yeah, sounds good.
All right. All right, talk to everyone later. Have a good week.
All right, have a good week. Take care.
Thank you. Bye.